Okay, I want to talk about inverse functions and trig inverses. Things can get a little tricky here. Let's start with an easy inverse function. F of x equals x squared. Inverse function would be the square root of x. Now remember that there's a domain range switch when we're talking about inverse functions. So if we're thinking about the domain of this function and the range of this function, we need to have a switch, a perfect switch happening here. This causes there to be a limitation on the domain of this. Why? Because if we think about the domain of this function, we know that that needs to be numbers that are from 0 and beyond, and that matches perfectly with the range of this function. But think about the output of this. The output of this, if this is blank, which really means it's positive, then the outputs, the range, are only from 0 to infinity. That means that the inputs have to only be of the original function. The inputs of the original function have to be from 0 to infinity. What does this mean graphically? It means that when we take, now this is going to be a sketch, so don't grouch at me. Okay, this is x squared. What I'm doing when I flip this is I am taking a line from y equals x and I'm flipping it here. And when I do that, this is fine, but once I do this, trying to flip this branch, I run into problems of functionality because now I'm violating the vertical line test. In other words, there's no way for an input of, say, 4 here to my inverse function to give me 2 outputs, right? This is the fact that it could really be positive or negative the square root of x. That's the inverse of x squared, but I can't do that functionally. I have to commit. I have to say it's either the square root of x or it's the negative square root of x, but it can't be both. So that's what happens here with this, is I am going to basically get rid of part of this as I'm thinking about the inverse so that I can have this perfect switch here. Okay, what's this got to do with trig? Well, with trig, we have the same problem because we've got this domain that in the original function would be kind of unlimited. Right, so if we're just thinking about the domain and range of this bad boy, well, the domain should be all real numbers, and the range is going to be from -1 to 1. Okay, so far so good. But what happens when we do the inverse? Well, now we have a problem because as we think about taking cosine, and let's just go forward. Let's go backwards. As I start to flip this across my imaginary y equals x line, I'm going to start running into vertical line problems. So I've got to limit the domain so that I don't have any of that kind of overlap. So you can think about it like in situations where I map a single value which is independent to a matching output that's the same as another one, this is where I'm going to get the problem, right? Like when I had f of x equals x squared, having the number 2 mapped to 4 was fine. And then -2 mapping to 4 was fine, but it's the reversal of that which is the problem. So for instance, with cosine, I'm going to get rid of this part here because it gives me all kinds of duplicated vertical points, which I already have accounted for over here. So basically from here on also I need to get rid of. It's just this little piece right here, which is going to give me all of the range coverage that I need. So going from a domain of 0 to pi gives me coverage from -1 to 1, unique mappings of numbers that go from a range of 1 at the beginning, and then they slowly get smaller, and then they get smaller and smaller and smaller and smaller, and they get down to -1. Then they start getting bigger. We don't want that part. So in other words, if we think about the domain range of this pair, we're going to have, we know that the range here goes from -1 to 1, which means that the domain of this is from -1 to 1. But the output of this has to be limited, and we limit it from 0 to pi. So that's the limitation on the domain here. So we get this perfect switch going on. Okay, so that's a lot of background. Let's talk specifics, right? What happens if I want to know what the cosine of a half is? Sorry, the arc cosine of 1/2 is. Well, think about turning this statement around. What I'm really asking you is, when does the cosine of theta equal to a half? Well, cosine of theta is equal to a half, and I'm going to go back to the unit circle here because this is probably the easiest way for me to mentally think about where that happens without a calculator. It happens up here because this is the one where this is the shorter part of the triangle. So talking about pi thirds. So in other words, the pi thirds input should give me a value of 1/2 when I test it. Now, when you do the inverse cosine of this, you're probably not going to see pi thirds in your calculator. You see the decimal approximation of that, which is why you really need the skills to be able to see this happening using that unit circle knowledge. So in other words, the inverse cosine of 1/2 would be equal to pi thirds. Okay, let's do another one using cosine again. Let's say we want the inverse cosine of -√3/2. So again, we're trying to find the angle that happens at. I can think of it as this question. When does cosine give me -√3/2? And that happens as we go to the back side of the circle, the second quadrant for cosines, the values turn negative, and I'm looking at the one that's over here because I want this longer x value. So that's the 5/6 value, right? And the way I came up with that was thinking, well, this is the one that's almost all the way over to pi, so it's 1/6 less than pi. So essentially in my head, I did a quick calculation of pi minus pi/6 to get the 5/6. So in other words, the theta here would be 5/6. This is the value of the inverse cosine. And you can see lots of different, forms of these questions. I can make them more complicated by doing things like, give me, I'm just going to erase all this. What is the inverse sine of the cosine of pi thirds? So now I've got two layers. I've got to evaluate this. Again, using the unit circle, pi thirds is up here. Cosine of pi thirds, that's a half. So then the question is, what is the inverse sine of a half? And so we're asking ourselves, what angle do we get a sine value of 1/2 from? And that happens at pi/6. Okay, well, I hope that helps get you started with inverse sine and cosine, and thinking about the inverse functionality and the domain range switch, all of that. Very, very important stuff, but depends on, how much you understood it at the time and how long ago it was since you thought about it. So that can be challenging. All right. Send me more questions.